Today I am going to talk about data drift in machine learning. This is when the data a model sees in the real world changes from what it was trained on, causing its performance to drop. We will look at why it happens, how to detect it, and what we can do to fix it. Now let's get started. What is data drift in machine learning? Data drift. This slide serves as the introduction to the core concept. It defines data drift as a change in the statistical properties of the input data that machine learning model receives after it has been deployed. The key consequences highlighted is that when a model encounters data that differs significantly from its training set, its predictive performance degrades. A clear example is provided: a retail sales forecasting model trained on historical in-store data will likely become inaccurate if consumer behavior suddenly shifts to online shopping as the new data statistical properties. Example: purchase items, basket sizes have changes. Why data drift matters for real-world impact. This slide outlines the critical business implications of ignoring data drift, moving from the technical definition to real-world consequences. It presents a table summarizing three major areas of impact. Reduced accuracy leads to poor decision making and ultimately loss to revenue. Compliance risks, especially in regulated industries like finance or healthcare, using a drifted model can result in legal penalties. Customer dissatisfaction, as models fail in recommendation or service, user experience suffers, leading to increased customer churn. The example given is a recommendation system losing its relevance. Next, a type of data drift. Data drift versus concept drift. This slide differentiates between two common types of model drift to ensure precise diagnosis. Data drift, which is covariate shift. This is a change in the distribution of the model's input features themselves. Example: the average age or income level of user changes. Concept drift. This is a change in the fundamental relationship between the input data and the target output variable. The factor that determine a successful loan application evolve over time. The slide importantly notes that both can occur at the same time, making detection and mitigation more complex. Detecting data drift statistical techniques. This slide details established statistical method used to quantitatively identify data drift. It lists four key techniques: Kolmogorov-Smirnov test, a statistical test used to compare two distributions and spot significant shifts; Kullback-Leibler divergence, a metric that measures the difference between two probability distributions, providing a quantitative score for drift; Population Stability Index, which is PSI, a widely used measure in finance. A value over 0.25 typically indicates a significant and critical change in a population. Chi-square test, used specifically to detect changes in the distribution of categorical features. Detecting data drift without labels, unsupervised methods. This slide addresses the common challenges of detecting drift when true labels, ground truth, are not immediately available in a production environment. It presents three unsupervised techniques: auto autoencoders. Anomalies and drift are detected by measuring high reconstruction error when the model tries to reproduce unfamiliar input data. Clustering. New data is compared to the cluster formed during training, misalignment indicates a potential drift. Feature statistics. Continuously monitoring simple statistics like mean, median, variance of features over time can reveal subtle distribution shifts. Monitoring model performance for drift. This slide focuses on the importance of directly tracking the model's performance metrics as a primary indicator of drift. It recommends three practices. Track key metrics. Continuously monitor standard performance metrics like accuracy, F1 score, precision, and recall over time for any downward trends. Analyze error patterns. Dig deeper into errors by examining prediction, confidence scores, and the specific types of mistakes being made. Segment performance. Check for localized drift by analyzing performance across different user groups, regions, or segments, as drift may not affect all groups equally. Handling data drift. Strategies for reliability. This slide transitions from detection to solution, outline strategies to maintain model reliability in the face of drift. The key strategies include retraining, establishing a process for regularly retraining models on new, recent data to keep them aligned with the current environment. Assemble models and domain adaptations. Using advanced techniques like assemble models, which combines multiple models, or domain adaptation methods to improve robustness. Automated alerts. Implementing monitoring systems that trigger automated alerts for proactive intervention before performance degrades significantly. Azure Machine Learning Model Monitor is given as a real-world tool example. Now, case study. Retailer shift onto online sales. This slide presents a practical case study that synthesizes all the previous concepts into a narrative. It outlines a 5-step story. Initial model. A model is trained on in-store sales data. Online surge. A marketing campaign causes an unexpected surge in online sales, changing the input data in data drift. Forecast drop. The model's accuracy declines, leading to operational issues like incorrect inventory forecasts. Early detection. A drift detection system identifies the change in data distribution. Performance restored. The model is retrained on the new online sales data, restoring its accuracy and reliability. This case study effectively demonstrates the why, what, and how of managing data drift. Thank you.